So hello everyone. In this session, we're going to start a classifier known as naive-Bayes classifier. So as you have seen that we have prior to this, we have covered the probability part because that was required for this naive-Bayes algorithm or naive-Bayes classifier. So it is a probabilistic algorithm. Okay, it's a probabilistic. So obviously there is the name Bayes, so it will use Bayes rule somehow, and then we'll see why this naive Bayes. Okay, we'll see that. So if you see classification, it lies in the heart of all the things. So let's suppose in humans or machine learning, everywhere you classify some things. Okay, so if you have, let's suppose, some documents and you want to see what is the sentiment of these documents, are they related to finance, are they related to education, are they related to something else? So you have to classify. You have documents and you want to classify, you want to tag them, and because there are tons of documents on the web, or maybe each document can be a book also. Which book is on? Is this book on mathematics? Is this book on chemistry, physics? And that's a classification problem. Okay, again in the sentiment analysis, so if you are given a review, so is this review positive or negative? People make humongous amount of money by this. Let's suppose Apple is releasing a watch, or Apple is releasing some iPhone or something like that. What people do is people will scrap the web and see all the blogs that are related to that Apple Watch and see the sentiment, how people are thinking about that. If they got the overall sentiment is that this product is really good or it is really nice, some things like that. So what they'll do, they'll buy the Apple stocks, buy stocks of Apple, and because based on the sentiment, because they see how the things are being perceived by the market. But if they see that the market is perceiving the thing negatively, they will short sell the stocks. Okay, and this way they will earn billions of dollars, not billions, and I'll say millions of dollars they can earn. So what they do is they're using these classification techniques. Okay, and even spam detection that we have been using as a running example. So in spam detection, so what we have, you receive an email, and now your Gmail or your Outlook, whatever mail you are using, that has to detect whether it's a spam or not spam. Okay, so all of these things are classification problems. So I'm just giving you an overview because these things we'll be using again and again in this naive-Bayes discussion. So that's why you must know these things. So before even covering this, so I'll just see and revise the basics of this naive-Bayes for you. So what we had is we had Bayes theorem. If you see that, so in that Bayes theorem, so we tried if we have probability of A given B. Okay, probability of A given B was written, if you see conditional probability, it was written as probability of B given A multiplied by probability of B divided by multiply probability of A divided by probability of B. Okay, something like this. So everybody understands this because I think we have covered enough of this background. This is, if you see, this is our Bayes theorem. In this, now we'll see it in the statistical terms, what these terms are called. Okay, they are named differently, so these things are named as differently. So this over here, so if you see this probability of A, so probability of A or probability of H is, this is called as prior probability. This is called as prior probability. They have specific names. Okay, then if you ask me what's this, so this is called as likelihood. Likelihood. Okay, and this here is called as evidence, and this is called as posterior. These are names given to these different terms in Bayes rule. So if you again remember these, so here we got, this is our conditional probability, and by the definition of conditional probability, so we'll expand the numerator. So this over here is likelihood, okay, and this is our prior belief, we called it. So many times we used prior belief, and this is, we got some evidence. Okay, so this is what we have seen so far. So now what we have is, we'll have, like in this terms of A and B. So in here we'll have some, let's suppose, probability of a class given some data. This is what we have to find. So in nutshell, what I'm telling you is that, so now you will be given some data. So you'll have a data point. So let's now define how data is there. So okay, data will be like this. You will have a matrix X. So in that you will have some features, F1, F2, F3, F4, something like this, and then you will have a label. Let's call that Y. Okay, and this will be one data point. So X1 will be our first data point. X1 will be like this, 0, 2, 4, 1, something like this. And label, let's suppose this is a classification problem. Let's talk with in terms of binary classification. This will be 0 or 1. Okay, and then we'll have X2, point number 2. So this will be some values over here. So maybe this is class 1. and this whole is our data matrix then. So the whole of this is all data matrix. This is x, and this whole vector over here is called y. Okay, so mathematically how do we write it? So we have been given xi comma yi pairs. This is supervised setting, okay, where I is equal to 1 to n, we have n data points, okay, and this xi, it belongs to rd, let's suppose this is a d-dimensional vector, so all the values are real, and this yi in classification, it belongs to 0 or 1, it belongs to this. So this is what our problem is. Okay, I hope that you all know this, so I'm just revising so that everybody is on the same page. Now we saw that. Now we'll see each of these terms. So now we have given this data. So I was discussing this thing. So now we have been given this data. We have some data as we are running this with spam example. Let's suppose we have this email data. So for each email, I want to see which class does it belong to. Okay. So in email, I'll have an email. So that will be my data point. So we'll also write the code for it. So for email, the first thing is we'll have to write its embedding. Okay, how to feed this vector, how, because email is just bunch of words and bunch of sentences. So how to convert that into numbers first. That's called an embedding. Okay, how to get an embedding out of that. Okay, how to get a vector, so that you will feed into that. Let's skip that step, because that step itself is a huge topic in itself. We'll see different techniques used. Let's suppose now we have an email that in the vector form. So this is our email. So it might have different features, x1, x2, x3 till some xd. These are d features. This is our email. Now what I want to do is I'll feed into this into my algorithm. Okay, and I want, this is called as inference, which, and from that I want to see what is the class it belongs to. Now I'm not talking about training part. So first see this. So this thing I have to feed into my algorithm, and then or my model, algorithm or model, and then I'll get some class out of this. So this is what I'll be doing, like in the broader sense. Now what I have to do is, if given one email instance, so this is my one email instance. So what is the class it belongs to? So basically in terms of probability, so what I want to do, because there can be k classes. So here we are taking 2 classes, so there can be more than 2 classes. So I want to see what is the probability of given this data point, given this data or given this email, what is the probability it belongs to class 1. So we'll compute this. Then we'll compute probability of given the same data point from class 2. Okay, we'll have to compute this. And basically we can write ci in general. So I'll just write in general format, what is the probability that this data point belongs to ci class. Now I can be binary, I can be multi-class, howsoever you like. Okay, so this is what we have to find. So this is called as posterior. So now you understood the concept of posterior, because you understood it in terms of probability. First we saw this is actually a conditional thing, some event happened, but you see that we observed some data. Okay, this is our observation, we observe some data, so that is with us, that is what we mean by event. Okay, so we have the data, and now what's the probability that it belongs to that class given the data point. Okay, that is what we see. This is called as our posterior. This is what we want to find. This is the main thing that we want to find. Okay, so we have different terminologies. I'll first clarify this. So we are now clear with the posterior. What is the meaning of posterior? So now what Bayes probability tells us, okay, so this is really hard to compute. Okay, so this is really hard to compute directly if you go into play and you observe one data point and then you directly see what is the class it belongs to. So what Bayes theorem tells us, it tells us, okay, you should do this. You should probability of, what's the probability of data given class, given a class ci, let's suppose. This is, and multiplied by probability of class. Okay, divided by probability of data. So now this is easy to compute. So if you see, this thing is very easy to compute. So let's suppose you have been given data, and you know you can use the frequent test approach to compute this, and we'll see how to compute this. First I'll talk about likelihood, what likelihood means. So probability of data given a class. Okay, so what's the meaning of this? So let's suppose now you have if you have a humongous number of data, now you have this data. Okay, this is our this is what you have collected. Okay, so maybe you have some 100 emails. So this is our 100 emails. So each of the row here is an email. So if these are 100 emails, so each of them will be belong to some class. So one will be from class 1, class 0, like spam, no spam, spam. Let's suppose this is my spam. This is again spam, no spam, something like this. So you can see that probability given this data, and it belong probability given a class 1. So this is easy to compute. You can use frequent test. Let's suppose we have spam emails. We have is equal to 50. This is like very high, like 30, I'll say 30, and no spam emails, that are 70 emails. So you can see that this is now easy. Probability, like given the whole data that we have, from class 1. So this is easy, 0.7. So the class 1, let's suppose we'll call this class 1. This is our class 1, and this is our class 0. So class 0 means spam, class 1 means no spam. So probability given the data. Now you have this data. Okay, what's the probability that we have this data and given the class 1? Now you saw that we have 70 points. So 0.7 is the probability. So this is easy to compute. Again, probability of the same data given that it's class 0. So what is that? That is 0.3. So this is the meaning of likelihood. How likely is the data? Okay, that's why it's called likelihood. Posterior is why it's called posterior, because posterior means something happens afterwards. Okay, that's why it's called posterior. Likelihood means okay, what is the likelihood? Okay, if we are given this class, so this is the class. So what is the likelihood of this? Okay, then we have this prior probability of probability of class 1. Okay, so here if you see this prior, so prior is defined as like directly probability of an event, probability of class 1 and probability of class 2. Okay, something like this. Okay, and I think here probably this will be somewhat different because we have to change it. So given the email, so this actually whatever I explained over here, this is actually likelihood. So this is probability of class 1 is, because out of 100 samples we have class 1 is 0.7, and out of these 100 samples we have, this is my class 0 and class 1. So this is 0.3 and this is 0.7. So this is my likelihood. So this is my what I say prior. Prior means I have this prior belief. Okay, and again coming to the likelihood, by likelihood I mean like let's suppose given this data and it will be, let's suppose a word will be there, so not whole data. So we'll see. So given the word, let's suppose a feature free, because in the mails you will commonly see free, buy, sell, something like this. Given this word, what is the probability that this word belongs to? And it's same, you have to count the frequency of the word free and how many classes it is in there. So let's suppose this contains free, this also contains free, this also contains free. So here let's suppose we have some 30 emails which contain free. Okay, 30 out of 100, something like this, or maybe 40 emails. So this is what likelihood means. So you don't have to take whatever I explained for this. So this was actually likelihood. So for this, so here we have prior. So prior belief is how many total emails we had. So we had total 100 emails. Out of them, we had 30% of emails which were spam, and 70% which were no spam. So this is our prior belief. So what is about this likelihood? So I'll also write likelihood here. So likelihood given that I observed data. So now we have different features. So I'll say probability of there is this word free in the data, and given that it is in class 1. So this is easy to compute. How can you compute this? You see all the documents where this free is present. Okay, I told you maybe there are, let's suppose, 40 documents in which the free is present. Now you have, in total you have 100. How many documents? How many emails you have? You have 100 emails. So 40 divided by 100. So this is 0.4. This is what I mean by likelihood. So how many? What is the probability of this word given that this is class 1? Let's suppose probability that buy is in the email, given that it is, let's suppose, class 0. Let's suppose this buy is in total it is in 20 emails, so 20 by 100. So this is 0.2. This is called as likelihood. Okay, prior is like you have some prior belief. Out of this, like total emails from the 100 emails, you see this on the labels. So you saw the labels, you saw that there were 30% of the mails which were spam and 70% were not spam. Okay, I explained you the posterior. What's the meaning of posterior? What's the meaning of likelihood? And what's the meaning of prior? Is everybody clear on these three at least? I cannot see the screen. Can you please confirm this?
Please confirm this.
Yes, sir.
Okay. So I'm getting an echo from somebody. If somebody is having microphone issues, they may not speak. Maybe Amir is having good microphone. Please, you speak on behalf of others. So I hope that this is clear now. So posterior, if you see, this is probability of my given probability of hypothesis given data. Basically, by hypothesis I mean class here. So usually if you see mathematics, we'll write hypothesis here because we have a discussion on hypothesis classes, and I don't want to get into that discussion, otherwise it will stretch. So probability of a class given data. So this is my posterior. Okay, now I'll have to expand this. So how do I expand this? By using the Bayes theorem. This is probability of data given the class multiplied by probability of the class divided by probability of data. So why did I not talk about evidence? Okay, because this is not required. Why is it not required? So what you want to do is, so let's suppose you have each data point now. This you will do for each class. Okay, so you have this probability of Ci. Okay, now you want to maximize. You want to take that data point where this probability is maximum. Okay, so how I can write it mathematically? So what is the point that we basically do in naive Bayes classifier? So in there, the whole point is to maximize this, for which class the probability is maximum, we'll say the data point belongs to that class. Okay, I hope this is clear. So what I'm saying is, I'm saying we'll compute the probability of class 1 given data, so there will be some value. Okay, probability of class 0 given data. Okay, and we'll see which of them is maximum. So which of them is maximum, we'll assign the data point that class. Okay, so how to write it mathematically? In mathematics we write it with argmax. So I'll write argmax of I, probability of Ci given data. This is what I want to compute. Okay, so I am saying whichsoever I is there and for which this is maximum, for which this thing is there is max in argmax. Max means the maximum value. Argmax is what is the value which makes it maximum. So here if I write maximum value, so if I write for example max of something, okay, max of there will be something, so that will give me the maximum value that this function has. So if I write argmax, so if I write argmax of some function, let's say f of x, argmax of f of x, so this means at which x does this function attain the maximum value. Is it clear? Difference between maximum and argmax?
Yes, sir.
So here what I'm saying is, I'm saying argmax of I. That means at which I, on which class does this probability get the maximum value. So that class I'll output that class. Okay. So whole of this, the output of this will not be probability. The output of this will be either class 1 or class 0. Okay. If I write like this, if I write maximum probability of, let's suppose, Ci given data. So what is the meaning of this? So this over here will actually give me a vector. So this will give me something like 0.2, 0.4, 0.6 if there are 3 classes. So if I write max of this, so I'll get one value, that's 0.6. Okay, so this is the value. But what if I write argmax? Okay, if I write argmax, so argmax of this 0.2, 0.4, 0.6. So let's suppose this index 0, 1, 2 index. So this index like this. So here the output now will be 2. Okay, that's the difference between max and argmax. Okay, now if I see this, so what is the point? I have to compute this probability of Ci given data, but mathematically I'll have to compute argmax. This is my problem. So this is the whole point, that we have to compute probabilistically. That's why this naive Bayes comes in. This is what I have to compute. So now I'll see how to compute this. Okay, now first I'll expand these things by using the Bayes theorem, and then we'll see how to use this argmax. So why I told you about this argmax, now I can drop this. So if I have to maximize this, so let's suppose if I can drop this. So because the point is I have to argmax it. So the thing is, if I just maximize these things, so this will be some proportionality constant. Okay, so it is irrespective of this thing. So if I maximize this, that means I'm maximizing this. Is it clear? So if I'm getting a maximum value, let's suppose for this part, that is equivalent, I'll get maximum value for whole of this equation. Is it mathematically clear?
Yes, sir.
Okay, let's suppose I am maximizing something. So if I maximize, let's suppose something divided by, like, let's suppose 2. Here we have a function f of x. So this means if I am maximizing this thing, obviously, like, divided by 2 will also get maximized. That's why I can drop this. I'll also give you the intuition idea, but I first want you to understand this mathematically. Because my point being, first you should be clear with mathematics, then you can build intuition around that. So here you can clearly see that this data, if you even drop it, if you want to maximize this, it is better you can maximize this. Okay, you maximize, because here the data is some sort of fixed, so you cannot do anything with data. So that's what I'm saying. This is constant for us. So this is constant for us. So I have to basically maximize this. So how I can write the problem? So I can write the problem like this: argmax of I, probability of Ci given data. So this is equal to probability of data given Ci multiplied by probability of Ci. Okay, so basically I have to argmax this, argmax on I. This is what I have to basically maximize. Is it clear? Okay.
Yes, sir.
If this is clear, so how I can expand this here? Now I can use, if you see this data, so data, how is my data? So data is basically I have probability of basically x given some class Ci. So this is how it is. So x here is, it contains different features. So this will be probability of x1 comma x2 till xd, because I have d features given the class, given class Ci. I'm talking about the likelihood. Okay, and then if this is multiplied by probability of Ci. Okay, multiplied by probability of Ci. Multiplied by probability of Ci. This I have to compute argmax. Let's drop this argmax. First we'll expand this and we'll see mathematically what is the answer for this. Okay. So now if you see this, so this is what I'm writing. So this numerator I am writing like this. Okay. This is probability of, I can write it now in the intersection part. So here you know that we can expand this in intersection. Okay, so you can write this as an intersection because you know multiplication rule. So probability of A given B was equal to probability of A intersection B divided by probability of B. Okay, so this part I can let's suppose I have to compute say probability of this, so I can write it like this. Okay, and this intersection part I'll use it here. So now I'll use, this is my part where I have this probability of Ci multiplied by Ci. So how I'll do it? So I'll compute the probability of, let's suppose, Ci, I class or kth class, whatever it is, and intersection with x1 comma x2 and so on xn. This is what I am like, I have to compute the joint probability. Okay, so this is what I'm interested in, computing the joint probability of Ci, and given all this is my whole x, so this is my x data point that we have. Okay, now first I'll analyze this part and then we'll see it. Is it clear till here, till this point? So basically this is the intersection part of this. So just consider this as one variable. So here, but I have a lot of variables. That depends on the data, how many variables I have in the data. That depends on that. Is it clear? Okay, this is what we are interested in. We are interested in calculating this. Okay, this probability of this. So if you see the again Bayes theorem, probability of A given B, that is equal to probability of A intersection B divided by probability of B. Okay, so here now we expanded this into two things. We expanded into probability of B given A multiplied by probability of B divided by probability multiplied by probability of A divided by probability of B. So this whole I am writing it like this. Okay, so that's what I wrote in here. So this is my probability of class given data, class comma data. Okay, divided by probability of data, and this is equal to probability of given data, and it belongs to some class Ci. So this is my whole thing that I have to compute. So what I'm doing is, now I want to basically use this part. I want to compute this separately. Now you know the data. So data, it is a set of features we have. That's why it's called, sometimes called as multinomial naive Bayes theorem, or multinomial naive Bayes classifier. Okay. So this is what I have to compute. This is my Ci. So that's what I have written here, and given data. So I can expand it like this. Is everybody with me? Is it getting too mathy? Then I can give you the intuition first. Is everybody with me?
Yes, sir.
Okay, so this is actually we had to compute probability of x comma this Ci intersection. I'll write it with intersection means comma. Okay, this basically means x intersection Ci. So this is actually equal to probability of x1 intersection x2 intersection with everything intersection Ci. So I am just removing the intersections. I am writing commas in that. So you'll see it done frequently, because I have told you that if you follow different literatures, you'll see either it is represented by this or it is represented by commas. So here if you see that, so basically I have to write a probability of class I intersection of x. So now you know that probability of class I have, just for notational simplicity, I can write it just with comma of x. Now I have expanded this x also, because this x, each data point, if you see, okay, this is, let's suppose, xi some data point. So this contains features x1, x2 till xd features. So this is what I want to compute, class I comma of this. Okay, I hope that you sort of understood this. Now we'll see in mathematics how to expand these things, and what is the, why is it called naive Bayes? Because you saw that it's called naive, it's called Bayes because we use the Bayes theorem over there. Okay, now we'll also see what is the naive thing that is there. Naive basically means like which is very simple. Now you have to compute probability of x1 comma x2 till, let's suppose, xd features we have comma c k r c I, ith class we have this. So this, if you take now the probability, we saw different rules, we saw conditional probability, we saw total probability rules. So how to expand this? So if we have this probability of A intersection B, so this we wrote as probability of B given A multiplied by probability of B, or we can also write it like probability of A given B. This is probability of A given B multiplied by probability of B. Okay, this is just a side note. So now we can expand this in the similar fashion. So we can write it like this: probability of x1, okay, given that x2 comma x3 till xd and ck and ci happened. Okay, so this is the first term, and multiplied by, so now we have to multiply it with this. So correspondingly we can write multiplied by probability of ck or this. So we'll also expand it like that. We'll simplify the equation. So this is my, I hope that you understood this part. So I said all of this happened. So probability of x1. This is just multiplication rule that we have done in the probability a lot. So probability that x1, given that all of this happened. and then probability of multiplied by probability of x2 comma x3 till xd comma ck. Is it clear till this point? Because I'm doing nothing, I'm just doing this probability of a intersection b, that is equal to probability of a given b multiplied by probability of b. This is what I'm doing. So if you see it over here, this is my, let's suppose a, and whole of this is my b. This is my a and this is my b, and this is, let's suppose this is my, over here I consider this as x1 given c, so this is my a and this is my b. Okay, now you saw this. So probability of a given b multiplied by probability of b. Okay, this is equal to probability of a intersection b. Is it clear? I hope this is clear. There should be no confusion. Then there is no point of learning probability, because we have seen a lot of
Yes, sir.
probability. I'll just remove these things. I hope that this is clear. So now if you can see this, I can again apply the same rule onto this. I can apply the same rule onto this x2. So I can write like this. I can write probability of x1 given x2 comma x3 till xd comma ci. So here is also ci. I means class. Sometimes I write k with the classes and sometimes I'll write I. So it doesn't matter. Okay, and multiplied by this whole thing. Now I can again write it like this. So I can again expand. I can write it probability of x2 given x3 x4 till xd, and what is given to me, c of I, and then I'll write probability of x3 x4 xd c I. Is it clear? So I can keep on expanding this like it. Okay, till I reach the last point. So if I now expand it, so this is probability of ci comma x1 till xd. So this is basically equal to probability of x1 given x2 till xd and ci multiplied by probability of x2 given x3 x4 till xd comma ci multiplied by probability of x3 given x4 xd comma ci, and it will go on till what, till probability till the end. So at the end we'll write probability of xd given ci multiplied by probability of ci, just using the multiplication rule that we have seen. Okay, so this is what I have written. Is it clear?
Yes, sir.
Okay, now let's see the physical example first, and then we'll expand it more. So in here we had these features. Okay, we had these features x1 x2. Let's suppose this is some example we'll take. Let's take an example first so as to clarify this. So example we had, so in here we had an example of, let's take some spam filter. Okay, we'll work with spam and no spam that we have been working with. So let's now say feature 1, feature 2, feature 3 and feature 4 are some features that we have been given. This is feature 1, feature 3, feature 4. Okay, so these will have some value. Based on these we'll tell whether this this can be presence of word buy, this can be sell, this can be, let's suppose, sale, okay, or some other words can be there, hello, dear, or something like that. So there will be words present. So this whole depends on what's the embedding. Okay, now we see that in spam filters, buy, sell, the sale, these sort of words will be frequent, and this word hello and stuff, and maybe words like dear and some things will be there which will be in both the emails. So that can be in the spam emails also, that can be no spam emails. So what I'm saying is now is that you see, if you have to compute the probability of class given the data point, given this data point, let's suppose this is data point x, given it belongs to class 1, or class 0 means here we have class 0 spam and class 1 means no spam. Given that this is no spam, or probability class 0 given this x, given this x and given this x. Now you have transformed this problem to just compute probability of these two happening together. This is what you have transformed, because we have to take argmax. That's why I can do this. So if, even with equality I can just try to proportionality. So c0 x. So this is what I have to compute. So how I will compute this? So I'll say, okay, what is the probability that this word is like what's the probability that both of these will happen? So buy and email is not spam. Okay, I'll compute this. I'll compute for all these features. Okay, we'll see that the physical example of, but I just here want you to wrap around your head around this example. So here we'll have features. So for these features we'll see how many features. So we'll take all these features and multiply them together. Okay, now you see that this thing is quite hard to compute. So if I'm being told compute the probability of feature 1 given that feature 2, feature 3, feature 4 is there and class 1. Okay, something like this. So I'll have data like this. I'll have data. So in the data I have feature 1, feature 2, feature 3, and feature 4, and I'll have class also. This is my class. So what I'm here, what I have to do is I am being asked calculate the probability of this feature 1. But given that these feature 2, feature 3, and feature 4 happened, so I'll first have to select all of, and it will be rarely some data point will be there. So first I'll have to make the okay, feature 2 is this, feature 3 is this, feature 4 is this, and class 1 is, let's suppose class 1 is over here. So for class 1 I'll have, let's suppose, some 20 data points. Among these 20 I'll have to exactly get match for these three features. Okay, it's like asking me, I'll just compute the probability of this feature given I have these three features. So this will be this is really hard. Why? Let's suppose I have value 0 0.2, 0 0.4, 0 0.6, 0 0.8 here. So what I'm telling is, I'm saying given these features happened, given 0 0.2, 0 0.6, and 0 0.8 happened, and with class 1, what is the probability of feature 1? So I'll have to compute all these data points. So rarely there will be anyone. So very rare it will be, there will be 1 or 2 data points. There will not be sometimes, because we want to find the exact match of features. For given this feature 2's value should be this, feature 3 value should be this, and feature 4 value should be this, and for this, they should belong to this class. Then what is the probability of feature 1? Do you see that this is really hard to compute? How many of you are able to see like this is really hard to compute? Even if you see in the real data, this always will be nearly 0 if you compute something like this. How many of you are able to see this?
Yes, sir.
Asrar, Zakir, Rian.
Yes, sir. Yes, sir.
So what I'm saying here is, so first thing is the class 1 happened. I'll take all the points that are in class 1 only. So let's suppose there's a subset of classes. Then I am again sort of conditioning it. I'm saying feature 4 should have this value, feature 3 should have this value, feature 2 should have this value, and then I'll compute the probability of f1. So that it will be very less, very like near to it'll nearly tend to 0. This probability will be nearly 0. So what here the naive assumption comes in. So here we have this naive assumption, because Bayes, it is called as naive Bayes classifier. So Bayes classifier because it uses Bayes theorem. So what is the naive thing here? So we make an assumption here. So what is the assumption that I'll tell you? So assumption that we make is that these features f1, f2, or maybe what are x1, x2, whatever we name them, till fd, these are independent. That is why we talked about independence in the previous class. Okay, these are independent. So if I have probability of f1 given f2, so what is it equal to? This is equal to probability of f1 multiplied by probability of f2. Isn't it like this? Because that is the definition of independence that we saw. So if we have independence, so this is the definition of independence. So this is what the assumption we make here. So assumption in the naive Bayes classifier is that these features are independent. This is very naive assumption, because you know that features are not independent. They are dependent on each other. Okay, but that's why it's called naive Bayes. And it performs really good, even if this assumption is really terrible. But still, when you actually implement this classifier, it performs really good for some tasks. Okay, now we'll condition this. So here we assume that all these features, so assumption is features are independent. So this is what my assumption is. So by that I can, if I have something like this, so I can write it like that's the meaning of independence. Now if I see this equation, if you see this equation over here, so this equation I'll use it directly. So what I can do is, so for this I'll write this is just probability of x1 multiplied by probability of x2, okay, multiplied by probability of x3 till multiplied by probability of x, and this is but continuously we'll have to write given the class, okay, for all given the classes, given class ci and something like that. So probability of this is my assumption, probability of x1, x2. So I can write it on the next page so that there is no confusion. So I'll take whole of this, I'll copy it. This part I'll take. Okay, so I'll write it over here. Now I'll make an assumption over here. Okay, what I have to compute? Probability of this is my computation. Probability class k given the data. This is what I have to compute. So for that I computed this. So here now I'll make this computation really easy. I'll see the independence. So here I'll see the independence now. So what I can write it like this. I can write it probability of this point x1, okay, and then given for the given class. For the given class, let's suppose class k we have, multiplied by probability of class 2 given class ck till probability of xd, dth feature given class ck multiplied by probability of ck. Okay, this I'll do it like this. This is because I made an assumption of independence. Okay, so is it clear? So I can write this like this. So this is basically proportionality. This is not exactly equality. So but we have to argmax this. Okay, argmax of this will be argmax of this. So the thing is we have to compute argmax of I. Let's suppose here we have this I, probability of C and I sometimes I'm using interchangeably. So class I given the data. So now I saw that by using the Bayes theorem I can use it like probability of again going back. So this is probability of feature 1 x1 given class I multiplied by probability of x2 given class 2 given class I, and so on, probability of xd given class I multiplied by probability of class I. Okay, so this I can write it like this. So this is argmax again. This is proportionality argmax on I. So this is proportional to argmax of I. So this whole I can write it like this: pi I goes from 1 to d, probability of xi given c. Okay, I write it j. So j over here. So this is ci and multiplied by probability of ci. So that I can write over here also. So for how many of you is this clear? I did nothing. I just used the assumption of independence. I said the features are independent, and for all of this, so what I did is I just made this independence claim. Is it clear?
Yes, sir.
Okay. I hope that this is clear, because we had again I'll write it. Please focus here. I had probability of class I given I had some data. Data was x1, x2 till xd. This was my data. This was my given data. So I said this is proportional to probability of class I comma x1 till xn. Okay, then I made assumption of the dependence. I said condition this is equal to probability of class I multiplied by probability of x1 given class I multiplied by probability of x2 given class I, and so on till probability of xd given class I. So this I wrote title like this. This is continuously proportional. So this is probability of ci. Pi means multiplication. So we have two symbols, summation and pi. Summation means sum. This pi means if you want to multiply these, because these terms are in multiplication. So I'll have to write probability of x j, let's suppose, comma ci. So j goes from 1 to d. So here it should also be 1 to d. Yes. So anybody has any questions? Somebody raised the hand. Okay, here we omitted that probability of data. Probability of x we omitted because we have to get the argmax. So that is the whole theory behind the naive Bayes classifier. It's called Bayes classifier because it uses Bayes theorem. It's called naive Bayes because it uses naive assumption. The assumption is that features are independent of each other. So can I conclude that you sort of understood this, so that I'll take a physical example where we'll sort of compute all these probabilities by hand to get you the clarity. Can I assume that mathematically you understood it?
Yes, sir.
Asrar, Zakir,
Yes, sir.
Yes, sir.
Salim.
Yes, sir.
Okay. So now we'll take an example. So I'm taking this, giving the credits where I took this example from. So this example is from a blog. This is called a Shutter Line. So this has, I think, written in, I don't know, some 2013 or something, but it's a really good blog. Okay, I'll take an example there. So what is the example? So now we have to go for playing. We have to go for playing outside, but it depends on the weather. Okay, how the weather outside is, and based on that, we'll go to play outside. So depending on the weather, we want to decide. Whether to go for a play or not. Whether to play or not. Now, if you see this problem first, the first thing is play. It means two classes. We have 0, 1. We have two classes. Yes or no. Okay. Yes, I'll go for play, and no, I'll not go. This is what I have classes. So in this weather, so I'll collect some features. So what are the features? The feature one is outlook. So how does the weather look like? For example, outlook can be sunny. Okay, the weather can be sunny, overcast, or it can be rainy. Okay, so this is my first feature. So these are my features. So I'll write features over here. So this is my features. So these are the values these features can take. They can take sunny, overcast, and rainy. So this is a set. So now another thing is, then I have temperature. So I'll have another feature of temperature. So temperature can take values of hot, like in Bangalore, mild, like in Kashmir right now, cool, maybe in Antarctica, something like this. So then I'll also take humidity. This is again a feature. So humidity can take value of high and normal. So we are not giving exact values, so we just give class values. So windy, so this can be weak wind or strong wind. So weak or strong. This is the weather information I have, and based on this, I'll have to decide whether to go to play or whether not to go for the play. Okay, this is my thing. So play here will belong to yes or no. Yes or no. I'll say no. So these are my features. This is my F1, F2, F3, and F4, and these are my labels. Yes or no. Okay, these are my labels. Everybody with me? Understood the problem statement? Now I'll be given some data. Okay, now I'll be given some data. So what is the data like? So I'll just paste the data. So I have this data somewhere. So this is my data. Okay, so this is the data. See overhead. So here I have data for 15 days. Okay. So data here is for day 1, the outlook was sunny, the feature first was sunny, temperature was hot, humidity was high, and wind was weak. So I'll not go for the play. So given these features, I did not went for play. So this is my data. Similarly, we can be given this data for the spam filter. So this word appeared, this word did not appear. That will be again solving in the next class probably. But here I first want you to get the hang of this. How does these things happen? Then we'll code it probably on some spam filter. We'll build a spam filter within the class, or we'll build a some document tagging, something we can build some algorithm. So here this is a just toy example. So for the second day it was sunny, hot, high, and strong. Again I did not go for the play. So then again day 3 overcast, hot, high, weak. Yes, this day I went for playing. So I hope that you understood this data. Now we have to learn this thing. So there we have this training phase. So how to train the classifier now? Training phase, because I told you in the machine learning pipeline we have this training phase and then we have this testing phase. Now we'll see what is the how to compute this training phase. So in the training phase, what we'll do is we'll take each of this feature. So we have to compute probability of given data. So this is my data. Okay, so I have to compute probability given a data, or should I go class here is class yes, or probability class no, given a data point. So this is what I have to compute. Okay, this is my posterior. This is I have to compute. Given I'll be given a data point. Let's suppose I have been given data on day 16. That is my testing. So first I'll see the training. So in the training we'll use this data. So in the testing we'll have to compute this given some new data point. Let's suppose on day 16. So we'll have to see which probability will be more. So the class probability which will be more, we'll assign that class, yes or no. Okay. Now we'll focus on this training phase, or we'll focus on this learning phase. Learning phase it's also called. So here if you see that, if you saw it in here, so if you see in our probability, so what we have to assume, we'll have to compute these things. We'll have to compute this, we'll have to compute this, we'll have to compute for all the features and class I. So we have to compute probability of class I given the data. Data is x1 till here we have 4 features, x2, x3, and x4. This is what we have to compute. So if you see from the naive Bayes classifier, we said this is proportional to probability of x1 given class for all the classes, class I, multiplied by probability of x2 given class I, multiplied by probability of x3 given class I, multiplied by probability of x4 given class I, multiplied by probability of class I. Okay, first I'll do it for class 1. So if I do it for class, because I have only class yes or no, class yes, class no. These are my classes. So what will this be? So this will be probability of x1, feature 1 given it is yes. Okay, similar for others, and at the end probability of class yes, it is yes. And then here for here it will be probability of x1 given no, probability of no. Okay, now we have to compute each of these terms. So I think this is easy. Okay, we have to compute for how many classes there is yes, and actually this yes happened, and what is the how many features of x1 has this value. Okay, so if you see in our terminology now, we'll have to compute probability of outlook, because we have 4 features. What are the 4 features? Outlook, temperature, humidity, and wind. So probability of outlook takes some value. Okay, it will take some value, because here in the outlook, if you see, there are different values. In the outlook we have sunny, overcast, rainy. Okay, outlook will take some value O. Okay, given it was from class, let's suppose yes or no. Okay, some class like this. Okay, yes, class, suppose class can take value B. So B will be some 0 or yes or no. And similarly, we'll have to take probability of, then outlook we have temperature. Temperature is some value T given class B. And probability, then we had humidity. Humidity will take some value H given class B. And probability, that last feature we had wind, it will take some value W given that class is play. Class is equal to play or B, something like this. So this is what we have to compute basically. Okay, here O is the value outlook takes, T is the value temperature takes, H is the value humidity takes, W is the value wind takes. So B here is class yes or no. So this is what we have to compute. So that's what I wrote here. Class X1 given Ci, class X2 given Ci. Then we'll see out of these two classes. So we'll compute this probability, it will get some value, we'll compute this probability. Now let's make these tables. Okay, we'll make the table. See how I make tables. So now I'll compute probability of outlook takes value O, outlook takes value O given classes yes or no. So I'll make the whole table. So how will this table look like? So this table will be something like this. Okay, so here I'll have the outlook values, which the values outlook will take. So outlook will usually take 3 values, which we have, and then we'll see the frequency. So we'll have frequency, then we'll have the probability of the class. So here I'll take outlook, okay, and then I'll take frequency, because I'll have to compute these probabilities. Now I'll use frequent test approach. So here I'll see probability of the class. So probability of each class, probability of class. Okay, so now outlook, how many values does outlook take? Outlook takes value sunny overcast, so it will take value sunny overcast, and the value is rain. Is everybody with me? Please focus here for next couple of minutes, and you will be able to understand whole of the algorithm. So now the frequency is that we'll have to see the frequency of, here we can have play is yes, play is equal to yes, and play is equal to no. Okay, and we'll have to see for how many data points does this happen. Okay, okay, and at here we'll have probability of class. So yes, no, again we have two classes. Now we'll see. So first we'll see how many sunny words were there. So we'll compute the frequency. For out we'll see for sunny what's the frequency of this word. So we'll see it. So we'll see the data. So maybe I'll just copy this data over here, copy this again, and we'll keep on revisiting the data. So I'll paste this data over here. This is my data. Everybody is with me? So here, please count the word sunny for the yes. Okay, so when it was yes and sunny, so see yes and sunny. So yes and sunny here, why is it? You have to see yes and sunny because that will fill over here. So we got frequency yes and sunny. Amir? So first we'll see yes. So yes is here, 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 and here. So where is the sunny? So sunny, I think is one is here. This is yes and sunny, and this is yes and sunny. Okay, so how many values? What is the frequency? 2.
2.
So I can write 2 frequency over here. Yes. Okay, and then I'll see for sunny and no, or maybe for first we'll see for yes class only because we have. And for overcast, how many words are there for overcast? So yes is on these. So I'll just mark these. So this is, so overcast is for this. Okay, overcast is for this. This is also yes. So
4.
here overcast also, here yes, it is 4. So how many values for rain now? So see, for rain and yes. Is it yes? So here, this is no. So yes and yes. So how many values are there? 3. This is 3. Okay. So again for the no class, we will see the same thing. So I'll fill the table. So this is 3, 0, and 2. So if you see this data, so from the data we are computing this. So you are first seeing this cell over here is for how many the play was yes and it was sunny for 2 data points. Overcast 4, rain 3, and similarly here. Now if you see it here, how many frequencies are there? So we will compute the frequency. So for yes class we had total 9. For no class we had total 5. Now we can compute the probability of this. Okay, so over here, out of these yes total points, we have 9, so this will be 2 by 9. So out of total 9 points, the sunny was only 2 times, so this will be 2 by 9. So what is the no? No is 3 by 5. Okay, because for no we had 5 total points, so 3 sunny appeared 3 times. Again, the thing is similar for this. This is 4 by 9, so this will be 3 by 9. Okay, similarly here it will be 0, 0 by 5, so this will be 2 by 5. Have you seen how we filled this table? So this is probability of class, this was frequency, and from frequency I want to compute the probability. Basically this is what I wanted. This is my probability. I wanted to see this is probability of sunny given class yes. This is what that is. This is probability of sunny given class yes. This is probability of sunny given class no. This is probability of overcast given class yes. Okay, now you saw how do you compute this. The first thing is we saw how many data points are there which are sunny and yes, and how many data points are there which are sunny and no. So you saw 2, 3, 4, 0, and you computed that. Total number of yeses there are 9, and total number of no there is 5. Okay, and similar thing we'll do for other classes as well. We'll do for temperature, we'll do for humidity, wind. We'll construct this table for each of these features. Is it clear? Is it clear?
Yes, sir.
Now I'll show you the table. I'll directly get the table. So that table looks something like, I'll show you that table. Maybe I'll show you the table here. So this should be visible now. Is it visible?
Yes, sir.
This is the table. So if you see it over here, this is my table. So that's what we computed. So we had sunny 2 points, and now we have all the probabilities. We have this 2 by 9, we have this 3 by 5, we have this 4 by 9, we have every table we have. Okay, so you can take a screenshot of this so that keep it with you, and we'll compute the probabilities. This is the training phase. We are learning things, and now we have, because we wanted to compute probability of feature, we have to compute probability of feature 1 given this data that we have to compute, and probability of feature 2 given the data, and we are computing all these. Now we have 4 features. That's why we constructed these 4 tables. This is table 1, table 2, table 3, and table 4. These are the 4 tables that we have in our hand. Take the screenshot so that we can go back to this. Okay, and I can go on the back on the screen here. So I hope that this is now clear to you. You can construct all these tables by just seeing the data. Okay, now we have these tables for this. So we have these sort of tables for this kind of data, and now we'll see what we want to compute. And one more thing that we have to compute is probability of classes. Probability of class yes. So probability of class yes is, I think it is 9 out of how many? 9 plus 5, that is 14, 9 by 14. And probability of class no, that is 5 by 14. This is their probability. Now we'll have to just compute this. We'll have to cover this. If given a data point, so let's suppose now I have been given a data point. Say I have been given a data point. So data point looks like this. So my data is, this is training is done because I learned all the probability that I have to learn. Now I have to make inference. I'll have to make classification. So classification, in that I'll be given a data. So I'll be given some data point, and for that I'll have to compute with which class does it belong to. So let's suppose for outlook I have been given sunny. Okay, then for temperature I have been given cool. This is my new data point. These are my 4 features: F1, F2, F3, and F4. So this is sunny, this is temperature is cool, and then I have been given humidity. Humidity is high, and wind. So I'll just write it like this. This is outlook, this is temperature, this is humidity, and this is wind. So wind here is given me strong. So this is my data point now. Now I have computed all the probabilities. If you see, I have computed all the probabilities, and from these probabilities now I want to see what is this. So I have to compute probability of class yes given this data, given the data point that we had. First I'll compute this, and then I'll compute probability of no. So what will this be? So this will be probability of first feature, that is sunny. Probability of sunny given yes, okay, multiplied by probability of second feature. Second feature is high given yes, multiplied by probability of strong. This is the third feature given yes. Okay, and what else do we have? Probability of high, probability of sunny, strong, and given class, and then probability of class. Probability of class yes, basically class yes. So these are the 4 things that I have to compute. The probability, the first thing is I have to compute probability of sunny and one more thing, probability of cool, because that's temperature. Probability of cool given yes. Now I have all these values in my table. So if you see all these values, probability of sunny yes, probability of cool yes, given yes, probability of strong yes, and probability of yes. I have all of these probabilities within my. If I see the table, again I'll show you the table. Where is that? So it is here. So you see this. Okay. Now the first thing that I have to compute is probability of sunny given yes. So that I compute probability of sunny yes. That is over here 2 by 9. Okay, you'll have to just look at the tables now. In the training phase, we'll prepare these tables and then we'll have to look it up. I assume that you have these screenshots now. I'll directly fill the values. So here if you see probability of sunny given yes, I have the table in front of me. So there you can also see this. So probability of sunny given the class yes, it is 2 by 9 multiplied by probability of cool given class yes, so it is 3 by 9 multiplied by probability of high given yes, so it is again 3 by 9. So probability of strong given yes, it's also 3 by 9, and probability of yes, it is 9 by 14. This is what we had, I think here. Probability of no is 9 by, probability yes is 9 by 14. So if you compute this probability, so this probability is somewhere equal to 0.0053. Okay, now what we'll do is we'll also compute probability of class no given data. So that will be equal to probability of feature 1 given our data point, whatever point given our class no, multiplied by probability of feature 2, what are the value of feature 2 was given our class no, multiplied by probability of feature 3 given class no, multiplied by probability of feature 4 given class no, multiplied by probability of no, probability of class. So again, if I fill these values, this was sunny and this was cool, then this was high, this was strong. Okay, you have these 4 values. So if you again fill these values, so you will see it is 3 by 5 multiplied by 1 by 5 multiplied by 4 by 5 multiplied by 5 by 14. Okay, for these values. So this is for class 3 by 5, 1 by 5, 4 by 5, 3 by, and one more 3 by 5, 3 by 5, and then 4 by 5, 4 by 15. This is for class no, this is for this. Okay, now if you compute this probability, so this is 0.0205. 205. So this is 2 probabilities we have to compute. So now if you see that this probability of data, probability of class no given the data is this, and probability of class yes given the data is 0.053. So now obviously you see that this is more. Okay, this probability is more. So what's the class it belongs to? So it will belong to no class. So by seeing these weather conditions, we can say that I don't want to go for the play. I will not go to play the game or whatever it is. So this rule basically is sometimes called as maximum a posteriori rule, that we will see. So we want to maximize the a posteriori probability, and you want to maximize this posterior probability. This is our posterior probability. You want to maximize it. This is called as MAP, maximum a posteriori. Okay, and we'll see these rules in detail. So how many of you have understood this by seeing this example? So we started with naive Bayes. So naive Bayes here means that it uses Bayes classifier and it uses a naive assumption. So what is the naive assumption? That the features are independent. So I'll write that features are independent or independent. So this is the assumption that we have. Okay, we can have a lot of discussion on these feature independent, but I first want you to learn the algorithm, and in the next class we'll code some example of maybe sentiment analysis or something. Okay, this is the first thing, features are independent. So we have to compute probability. The problem is argmax. Let's suppose we have this class I, so probability of Ci given our data. So this is what we have to maximize. We saw that this is proportional to probability argmax of. So it's basically equivalent to computing this argmax of I, probability of Ci given the data. Data is x, maybe data, and then we saw that this data can be represented probability of Ci, comma x1, comma x2 till xd, how many data points that we have. Then we use that rule that each feature is independent. So that we said probability of x1 given class Ci multiplied by probability of x2 given class Ci, and so on till probability of xd given class Ci multiplied by probability of class Ci. Okay, and we have to maximize this value. So this is again argmax is continuously there. So this is my argmax of argmax over I. This is called argmax over I. Okay, then we can write it in shorthand like this. So this is argmax of I, P of Ci, pi I goes from 1 to d, probability of feature 1, that is x, probability of x, let's suppose we'll call it j. So probability of j given class Ci. Okay, so this is what I have to solve. So I said that for this in training phase. So in training phase, what do we do? So we compute the frequencies. Basically, we compute this probability of given a feature. So feature one takes a particular value. Okay, given a feature one takes a particular value for a given class. Let's suppose class value is some I. Okay, and we prepare those tables in the training. And once we get all of these features, then we in the classification phase. So in the classification phase, you just do one thing. You will just look at have a look up in the tables and see these probabilities which you have computed. Probability of xj given ci. You see these probabilities, and then you fill this formula and see where do we get the maximum value, for which class do we get the maximum value, and that class will output. Okay, and this rule I told you is called as maximum a posteriori probability. So we try to maximize the posterior probability over here. So now we also gave the example of this where we had these features. So features we had. So we had this data was given to us. So there we had 4 features, and each feature took some values. So outlook took some value, temperature took some value, humidity took some value, and wind took some value. And based on that, we computed tables like this. For each feature, we compute these tables. So this is nothing. So if you see it over here, so what is this? So this is probability that the outlook takes value sunny, given that this is from class S. Okay, and you have to interpret these probabilities like that. So if you see this probability, so this over here is probability that outlook takes the value rain, given that it's from class S. Okay, that's what we have to fill basically. So these are all things. And if you see, let's suppose over this, so this is probability of sunny. The outlook is basically sunny, given it is from class no. Okay, so I'll just ask maybe Amir, because this is really important. So Amir, what is this value? 4 by 9. So what is this value in terms of probability? Just 4 by 9.
Sir,
so this is probability that this outlook will take value overcast. It will take value overcast, given that it belongs to class S. Okay, this is how we computed it. So how you saw that how we filled this table. Okay, coming back to Zakir. Zakir, what is this value representing? This value 0. So what is this in terms of probability?
Sir, it simply means probability that the class outlook will take last class. What is that, sir?
Outlook.
Friends.
It is overcast. So this is 0 value. This is overcast.
Overcast.
Overcast. Given that it belongs to class no.
Class no. Right, sir.
Yes. So these are the values that we basically have to fill. So if you just construct this table, after that, what you do is you just see these probabilities from the table, and then afterwards you can just fill it. You can just fill it in the formula and just get the result out of this. And when you see for which class do you get the maximum probability. I hope that this, please and please, if it is difficult for you to grasp or difficult for you to understand, because there's a lot of material that we covered, go through it once again and see this, because now it will make sense to you. Okay, and the assumption here is that we consider this all the features are independent. So for independence, we know that we have that if we have two features, probability of A intersection B, this is equal to probability of A multiplied by probability of B. Okay, that is the assumption that we made. That's why it's called naive Bayes classifier. So for naive, it makes this assumption. I hope that this is clear. So I'll stop the session over here. If you have questions, I'll take the questions in next 5 minutes.